My name is Ben Rogers from Hexagon, Senior VP for APAC, and only recently new to Hexagon, but have spent the last almost 25 years in the industry, be it in the stevedoring industry or the mining industry, doing heavy machinery automation. So automation, technology, data, AI, we'll come up with another buzzword fairly soon, is all part of what excites me, and also excites me to be part of Hexagon. So today what I want to talk about really is that journey. Is that journey from a manual operation into a semi-autonomous operation, into a fully autonomous operation. And some of the lessons learned that I have through that 25-year journey as well. And some of the, I guess, the insights that we can help with. So when I start thinking about manual operations, we all know our operations have got larger and larger. We've gone to larger trucks. We've gone to more tons material moved on a daily, weekly, annual basis. But that also creates a challenge and a problem, right? We've got a lot of data associated to that. We've got a lot of information that people need to take in order to be able to make their daily decisions as well. We also then start to see, safety coming into, over the last 2 decades, safety coming into the environment as well, right? So now safety starts to become an important part of the everyday operations as well. So from that, we have people turning around who are on an 8 and 6 roster or 2 and 1 roster, etc., right? And they're trying to make decisions based on all of this information and data. So it's a very manually driven scenario. Not one person on the mine site knows everything that is occurring, compared to a number of decades ago with smaller mines. So we start to shift towards semi-autonomous, right? And if I had $1 for every time I had a debate about the word autonomous, I'd be living in Mallorca somewhere, right? In a quite a large house. Because to me, autonomy is everything from data autonomy to machine autonomy, and to changing your processes as you go through that journey. So we start to see semi-autonomous, right? And in this phase, we start to see machine guidance. We start to see fleet management systems helping our operators decide where should this next truck go, right? Where do we need to send the waste? Where do we need to send the high grade? We start to see safety components coming into that. We start to see people being removed from the pit. Right? We don't have spotters out there spotting, the face. We don't have painted rocks on the drill pattern, right? Turning around and showing us where to drill a hole. We're removing the people from that scenario. If we come all the way through to full autonomy, right? And there's a number of mines out there. I'm sure we could all mention a number of them that are in that full autonomy state. We have autonomous drills. We have autonomous trucks. We got autonomous trains, autonomous water carts. The last presentation had a number of those listed out there as well. But what comes with that also is even more data. So how do we actually use that data? And we've heard a number of sessions today, as well as this week, about AI, the onslaught of AI in order to help us work through that data. So that's the landscape of where we've come from manual, semi-autonomous, into a fully autonomous mine. But one of the questions I often get asked is, what does Hexagon have? Where does Hexagon fit into this picture, right? So I want us to, work a little bit here around where do we play, so to speak. So you should be able to see up there we have the value chain of a typical mine site from exploration, drill and blast, load and haul, crush, and plant, and then into reclamation at the end of that mine. So one of the things that excited me about Hexagon is we have that value chain, right? So if I start looking at the mining division where I sit, we have mine planning. We have BMI and BMT, so blast movement technology in that drill and blast space. We've got a tier 1 FMS system that can optimize a mine site and do that fleet management side of things. We've got safety systems, which I'm going to come to a little bit more. And now we're starting to turn around and move into that autonomy space, be it teleop remote control or full-blown autonomy with road trains that we're doing in Western Australia. So therefore we have a number of workflows as well. From the insights aspect of things, James Dampney, our head of product, talked about those yesterday. We have automation, which I'm going to touch on a little bit more, and ultimately our safety systems, which are in there as well. So Hexagon does have that life cycle, that value chain of the mine, and probably one of the few METS companies that has that all the way across the value chain. So let's touch on three components of that in the vein of automation. So our vehicle analytics, our vehicle collision systems, right? So what we call CAS, right, is really working in that MERS level 7 and level 8. It's detecting through sensors on board those vehicles, right? When is a vehicle in proximity of other pieces of equipment within the mine, right? And this is giving alerts and alarms to the operator in order to help with that collision knowledge. We also have RFID style tags which people can wear, which you can walk in and around those pieces of equipment in a safe environment. We then go through the next level, MERS level 9, where we get to VIS, what we call Vehicle Interaction System. So this is where we tap into the control system of that said vehicle and are actually able to stop the vehicle before an accident happens. And one of the powers of Hexagon is we're vendor agnostic. We're going to hear that a little bit through this presentation, right? We'll plug into any vendor that is out there in the hall or on the market in order to be able to use this technology for people. More recently, we purchased a company in the last number of years called Hardline. Hardline is teleop, remote control, right? So again, vendor agnostic, works on 80-odd different types of equipment in the market, has focused on underground, but we start to see that in the surface mining area as well. If you've seen our booth this week, we've got a Hardline chair out there. You can have a drive of a bogger. All the way through to full autonomy. And this is another area of uniqueness, right? We often turn around from an autonomy point of view in our mine sites, and we have a vehicle which is kitted out with a number of sensors, and then we have a back-end system that is orchestrating and giving path conformance to those vehicles. If we take a look out in industry beyond mining, etc., into the automotive industry, a Tesla vehicle, a BMW vehicle, some of these new EVs that are coming out, they don't have a supervisory control. The vehicle itself has to be ultimately very smart. It has to navigate between other vehicles. It has to navigate around people, stop signs, etc. So one of the things that we did is when we looked out into the future of what does automation, full-blown automation look like, we said we need to change. We need to change some things here, because the way that we've been running automation from a mining industry of trucks is not going to scale if you're going to talk 200, 300, 400 sets of pieces of equipment. So what we did is we brought technology from the automotive industry. So our technology vehicle is very smart, and the supervisory control is really just giving messages. I want you to go in this general direction. You sort out how you get from point A to point B. So Hardline, okay, teleop, right? So this is where we use remote control connected to multiple different types of vehicles, as I've been talking about. Brand agnostic, so we can connect to multiple vehicles from the one chair, mind you, right? So we also look at that from a people point of view. So significant look and feel, same look and feel across that spectrum, so that people can turn around and move from OEM 1 bogger to OEM 2 bogger to a truck to a drill, etc. And the same look and feel from the same console is there. But because we turn around and have some of that in automation mode, we therefore have LiDAR sensors and a bunch of array on board that vehicle, so we can use it for other pieces of work. So we have teleop auto. So remote control at the two ends, say from a bogging scenario, but in between that, from point A to point B, it will automatically move given the sensors that it has on board between those two locations. We also have teleop assist. So teleop assist is where we can turn around in remote control or on board vehicle, and with the sensor array that we have there, we can prevent the vehicle from hitting a wall as it's moving down a drive, etc. So what we're starting to find is automation is not necessarily there just for removing people, so a cost. It's there for equipment damage, for productivity, and so forth. So the sensor array that we have on a large haul truck or a large road train here, and so lots of people do know about this project that we're running in Western Australia. It's 150 kilometres out from point A to point B, 120 trucks running across that road, 80 kilometres an hour, 330 tonne, right? One of the challenges and the partnership that we struck here was the average age of a heavy haulage operator in Australia at the moment is 58. So if you have 120 trucks that you need to put a person in across 3 panels, that's almost 400 drivers that you need to try and find. With the average age of a heavy haulage operator of 58, you're just not going to be able to find that many drivers. Considering this is a 330 tonne, at full capacity momentum moving down the street, we're not taking an operator from the streets here in Sydney driving a Coles truck and putting them in that vehicle in the Pilbara. There's a hell of a lot of work that you're going to have to go through. So therefore, how do we turn around and automate it? And this is where what we've done at Hexagon is start to bring together the array of technology that we have. So I talked about our CAS system, collision avoidance system. So on the right-hand side there's a smart antenna, the small white dome. That's vehicle-to-vehicle communication. That's vehicle back to base communications. It's GPS information that we get off there. The call box that we use in our fleet system is the call box that sits on board that vehicle as well. We have a screen on there if we need to move between manual and auto mode, again, that we use from our fleet system as well. On the top left and right, you can see small black antennas. There are personal alerts. So between person and said vehicle, that interaction we can track as well. Our 4D radar is used in our vehicle interaction system. So when we want to stop a vehicle, that 4D radar is used there as well. And we also take some of our fly-by-wire technology from our hardline and other products that we have. So what we've done here is actually combine together the technology that we have within Hexagon in order to turn around and create an autonomous vehicle. We then layer that with a fleet management system and a supervisory control system as well. So naturally, the benefits of full automation, as we've heard, is operator efficiency, lower cost, given people, right? But I'm having more and more discussions in my role. It's not necessarily about the people, it's about the productivity, it's about equipment damage, and I think in the early stages of autonomy, back in the 2011s, 2012s, 2013s, when some of the large mining companies were starting to do automation, we weren't seeing the less fuel or the less wear and tear. As we've got smarter and smarter with that technology, we're absolutely seeing less fuel usage and less wear and tear on the vehicles. We naturally have an increase in safety as those vehicles are not in harm's way and are driven in a logical manner. But it's not for everybody, right? And this is where the journey of automation and the spectrum of automation really comes into the picture. And it's something I want to touch on from my learnings over the last 25 years or so. I, and as well as I'm sure you have seen many projects that have taken way too long in order to implement, because we've tried to go from zero to hero in one step. So the approach here that I would like to outline is, if we think about that manual operation, okay, we need to be thinking about our people, our processes. What's the processes that we have in our manual operation? As we shift into semi-autonomous, What's the incremental step we're going to do from an autonomy point of view to bring people on that journey? What's the incremental change we're going to do from a process point of view to bring people on that journey, right? If we go into phase 3 of the workforce, how do we need to reskill our people? What's the uplift in training that we need to do? Where are we going to run our control centres from? How can we turn around and keep people in the workforce, right? By having those control systems in major centres or towns, not necessarily in the middle of nowhere. And then ultimately, we now have all this data. How are we actually going to use AI to help people and not throw them a hell of a lot of data and say, you work it out, but actually have user-centric design, alerts and alarms for people to actually be able to interact to. That's the critical bit at the end of it. But notice, as I said, all the way through that, I hardly mentioned the word technology. The tech's done. Everybody has an automation system, right? You've got, 1,500 trucks, as the previous presenter showed, haul trucks running around, 600 odd drills running around, autonomously. The power in doing autonomy is actually the transition from manual to autonomy and going through the change management, going through the process change. So a catchphrase I often used to use was, if you try and automate a manual process, you probably deserve what you get. Right? And we've all seen projects that haven't quite worked exactly because of that. If you turn around and really look at your manual process and say, do I understand my autonomy stack that I want to use? How do I change my manual processes to fit in with that autonomy stack? You're going to get a lot more value from that scenario. And that's what we at Hexagon want to help people with, right? That's what we know. That's the context that we can bring from the mining expertise and the history that we have of going on that change journey with people. So, I'm not expecting people to read all the writing on this. So I diverted from my normal view of a slide with minimal writing. But there's a point behind this, right? Which is, back earlier this year, we turned around and we had a user forum in WA. So we got together 70 to 80 leading, experts around Perth and beyond, right? Be it some of our customers, potential customers, consultants, etc. And we came together as a group to do a thought leadership piece and say, what does mining in the future look like, right? And I asked the group an interesting question. I said, well, what does mining in 2030 look like? And we got some answers. And in reality, 2030 has already been set. They're all in a greenfield site that's going to start in 2030. They're all in PFS and FS right now, right? So the real question is, what does mining look like in 2050? And we start to see a lot more things like ESG, decarbonisation, workforce, technology that we don't quite know yet, right? We don't know what we don't know from a technology point of view in that space. Roles, responsibilities, right? Where are people working, right? So it was a fascinating discussion and reaffirms some of my beliefs and comments that the next step on that road to automation is really focusing on our people, on our change management, and what's the processes we're going to change in order to get there. So we will be releasing that information as a thought piece. So please, all the socials, LinkedIn, etc., hit it up, and we'll release that piece to everybody. So hopefully that has been useful. Some insights from my point of view. The booth is still open. If you want to drive a bogger in simulation mode, come and see us. But thank you.